Hello, today we are going to talk about MDIT IGCSE Physics 0625. First topic, motion, forces and energy. 1.5 forces, 1.5.1 effects of forces. Supplement. Under the supplement part, number 9, define the spring constant as force per unit extension. Recall the equation K is equal F of X. 10th one, define and use the term limit of proportionality for a load extension graph and identify this point on the graph. An understanding of the elastic limit is not required. 11th one, recall and use the equation F is equal ma and know that the force and the acceleration are in the same direction. 12th one, describe qualitatively motion in a circular path due to a force perpendicular to the motion as A, speed increases if force increases with mass and radius constant. B, radius decreases if force increases, with mass and speed constant. C, an increased mass requires an increased force to keep speed and radius constant. F is equal mv square divided by r is not required here. So this highlighted what we are going to talk about today. Hooke's law. Hooke's law states that for a spring, F is equal kx, where F is the force applied to the spring in newtons, K is the spring constant in Newton per meter, and x is the extension in meters. F is equal kx, K is equal F over x. So spring constant is force per unit extension. Limit of proportionality, you can see this force extension graph in a linear, straight force extension graph. Elastic deformation following Hooke's law, we call elastic region. The point it stops being linear is called the limit of proportionality. From then on, it does not obey Hooke's law. Limit of proportionality, point and which load and extension are no longer proportional. F is equal ma. Newton's second law states that the acceleration of an object is directly proportional to the resultant force acting on the object and inverse proportional to mass. So basically, F is equal ma. Always the resultant force and the acceleration are in the same direction. Circular motion. An object at steady speed in a circular orbit is always accelerating as its direction is changing, but it gets no closer to the center. For an object moving in a circle with constant speed, the speed is constant, but the direction is always changing. This means the velocity is always changing. Therefore, it is accelerating and there must be a force perpendicular to its velocity towards the center of the circle because centripetal force. Centripetal force, it is the force acting towards the center of the circle. It is a force that is needed, not caused by a circular motion. For example, when you swing a ball on a string round in a circle, the tension of the string is the centripetal force. If the string is cut, then the ball will travel in a straight line at a tangent to the circle at the point where the string was cut. Newton's first law. Mass and radius constant. At that time, we can see light is the centripetal force 1, F1, and speed 1, S1. And here centripetal force 2, F2, and speed 2, S2. When centripetal force 2, that means F2 is greater than centripetal force 1, F1, at the same time, speed 2, that means S2 is greater than speed 1, S1. That means if the centripetal force increases, the speed increases. Mass and speed constant at that time, we can see centripetal force 1, F1, radius 1, R1 there. And centripetal force 2, that means F2, and radius 2, R2 there. So we can say centripetal force 1, that means F1 is lesser than the centripetal force 2, F2. And radius 1, that means R1 is greater than radius 2, R2. So radius decreases if force increases. Speed and radius constant. So here we can see centripetal force F1 and mass 1, M1. So centripetal force 2, F2, and mass 2, M2. Here mass 2, that means M2 is greater than mass 1, M1. Centripetal force 2, that means F2 is greater than centripetal force 1, F1. At that time, an increased mass requires an increased centripetal force. Newton's third law. If object A exerts a force on object B, then object B will exert an equal but opposite force on object A. Or more simply, to every action there is an equal but opposite reaction. Centrifugal force, also known as the non-extension force, is a force acting away from the center of circle. This is what makes a slingshot go outwards as you spin it. The centrifugal force is the reaction to the centripetal force, called Newton's third law. It has the same magnitude but opposite direction to the centripetal force, equal but opposite.